Okay, so now let's tackle the second half of the problem, which really requires you to graph your function in order to see what's going on here. So when you're graphing quadratic equations or anything with curves, I actually recommend that you do 5 points instead of the usual 3 so that you can get a clearer idea of the shape of the curve. Now, from the last part, the first part of the problem, we already know one of the points because clearly the vertex is going to be a point. So I've already written that one in here. And what I recommend is from whatever your vertex is, specifically the x value, that you go 2 units to the left and 2 units to the right for your other 4 points. So since my vertex is at -3, +2, right here, I'm going to find what the y values are for -4 and -5, as well as -2 and -1. So that's where these values come from. And to do that, it's as simple as just plugging in this value, since it's an x value, in for x in your original equation. Now you can use either this one or the equation that you found by completing the square. It doesn't matter, they're the same equation, just in different forms. So I'm going to use this one just because I think it's easier, but that's personal preference. So I'm going to do -2 times, and now I'm going to plug in my -4 here. And again, keep in mind that that negative is getting involved in that square. So this is different than just doing -4 squared, because in this case, the negative is not involved in what's being squared. So make sure you keep that in mind. This represents -4 times -4. This represents -4 times 4, which they end up being very different answers. So make sure you're cognizant of that. All right, so then we've got -12 times -4 -16. Right, so if we work this out, -4 squared is again -4 times -4, so that's +16. And +16 times -2 is -32. And then we've got -12 times -4, that's 2 negatives, make it positive, so that would be plus 48. And then on -16, if we work all this out, you would have positive 48 minus 48, so this all ends up being 0. Okay. So I have another point at -4, 0. Okay. Now I'm going to repeat that process for all of these. I'm going to just kind of write in the values. Feel free to check my work, but this is going to be -6. That one is 0, and that one is also -6. So if I go to graph this, I now have a point at -5, -6, which is right here. I have a point at -2, 0, and I have a point at -1, -6. So I can see my graph is a parabola that opens downward and looks kind of like this. Okay, so now I'm ready to tackle domain and range questions. Now again, as a reminder, the domain stands for all the possible x values, the range stands for all the possible y values. And for these problems, for quadratic equations, it's going to be very rare that your domain is not all possible values of x. Because if you think about this, I know it looks like they kind of taper and end down here, but just imagine that these go off into infinity. These legs will keep getting larger and larger and larger, and can extend to all values of x. So the domain, let's see if I can, I'm not sure if I can write on the blue, let's find out. The domain is going to be negative infinity to positive infinity. The range is the thing that's going to change from problem to problem. You will generally have restricted values for your range, because again, this is all possible values for y. Now, if we look at it, this is the highest possible y value that this graph gets. All the other y values are down below, right? So the highest possible value for y is 2, and then it can be anything less than 2, because anywhere on this graph we've got y values along this negative axis, right? So the topmost cutoff is at positive 2, and it's included, because that's a closed dot, use a closed bracket. So that's the uppermost value, and again, the lowermost, well, again, these legs are going to extend off into infinity, so the lower end for y is going to be negative infinity. Wow, that's a horrible infinity sign, but trust me, that's infinity. Okay, so there's domain and range. Now, they want to know they want you to define the intervals where the function is increasing and where it is decreasing. And the way I like to look at this is kind of start from, wherever you can on your graph, the lowest possible point, and ask yourself, okay, as I move this direction, always going from starting on your left and going right, as I move up, because you're increasing in x values as you go in this direction, right? Because we were starting at essentially -5 and working our way towards positive values of x, right? So as x is going up, I'm asking myself, is y going up or is y going down? Are my y values increasing or are they decreasing? So if I start here, I have a y value at, I guess one of our points was -6. So when x was -5, y was -6. If I go over to x is -4, y is 0. So y has increased over that particular interval, right? So as x increases, y is going up until I get to this point, right? Now if you look at what happens after we hit the vertex, as I keep going in this direction, so here when x is -3, y is 2, but now as I move over to -2, y is now 0. It's gone down from the previous point. So now y is decreasing after I hit where x is -3. So for this particular problem, this function is increasing from where the values, and again, we're looking at values of x here, from where x is -infinity, because again, as we go further and further down here, we imagine extending this line out as far as it would go. For all these values of x down here, as we come upwards in x values, this line is coming up, going upwards. So that's another way you can think of it. Is the line kind of going up, or is it going down? So if the line is going up, it is increasing. If the line is going down, it's decreasing. Don't let those arrows kind of fool you. So it's increasing over the interval from -infinity up to 3. And it is decreasing from 3 onwards. 3 up to positive infinity for x. Oh, I'm sorry, those are negatives. That's at -3. Again, we're looking at x values. Okay, now, why do I have, let's see, oh, these are actually supposed to be, so these are closed brackets. My apologies, I get in the habit of drawing open ones whenever I have infinity involved. So, the interval is both, just to confirm, the interval is increasing as we move from left to right along the x-axis up till this point, because as we move along here, the y values are going up, and then it starts to decrease once we hit the vertex and start going onward. All right, please let me know if you have questions.